Hello, everybody. Good morning slash almost afternoon. Thanks for joining us for today's Lean Bites. Today we have Scott talking about how to safely evolve legacy code. So I'll turn it on over to you, Scott.
Well, thanks, Lise. So as Lise mentioned, I'm going to be talking about how we safely evolve legacy code. So just some high-level goals today. I'm going to talk about some ideas for how we can safely evolve legacy code from the state that it's in today to the value we need to get out of it tomorrow. And this is not about doing the full-blown rewrite. This is about evolving the code from where we're at today to where we need to be tomorrow. So we're going to talk about what is legacy code, just a level set. We're going to talk about options for how we can make these changes in a safe way, and then kind of step-by-step process on what you can do to safely go through and go about making these changes. So first off, let's talk about what is legacy code, because that might mean different things to different people. So I really like this quote by J.B. Rainsberger, where he said, legacy code is valuable code we're afraid to change. And I think there's two key parts to that quote. And the first part is valuable, right? So if the code's not valuable, we can just throw it away and start over, and it's really no big deal, right? But oftentimes legacy code is, the code that the business relies on and runs on and is a very critical component to the business domain that we're in. So I think the valuable part of this quote is something to call out, as well as the part where it says we're afraid to change. So one reason why we might be afraid to change it is the quote from Michael Feathers that legacy code is code without tests. Because, if we come into code without any tests, it's really hard for us to have confidence that everything is working. So what are some characteristics of legacy code? It's really hard to understand. You might look through it and, what it's doing doesn't really make a whole lot of sense, or there's a lot of indirection, or things are poorly named. It's a 1,000-line function, whatever it is. It's just really hard to follow. And oftentimes, like changing some code over here breaks something else in the application over here, right? So there's not really good vertical slice separation between the different parts of the application. Things are kind of all tangled together in a big mess. As well as if you hear when you're in stand-ups and stuff like that, things are taking a while, that can also be a sign of legacy code, like adding a new column to a table or something like that takes days or weeks. That might be a sign that we've got some legacy code on our hands as well. As well as third-party reviews. So I've been a part of some situations of like, hey, come in and assess our code base and give us what your thoughts are. That's usually another sign that we've got some legacy code on our hands, because usually those types of reviews don't happen on code that isn't in some state of mess. All right, so now that we've kind of talked about what legacy code is, let's talk about how do we tackle it. So let's say you're in a situation where, a request comes in and it's like, hey, we need to make a change to, that app, right? Like we've all had that app, and you might be dealing with one right now where you see a request come in and you're like, oh, I really don't want to make a change to that thing because it's just really hard to deal with, right? But that is a reality. So what options do we have? The first option we have, it's what's called edit and pray, where we just make changes to the code and pray that we didn't break anything. That is an option that's on the table. Another option is we declare bankruptcy and say, okay, we're going to rewrite the whole thing, right? This time we won't make the same mistakes we did before and everything will be great. That's another option that we have. Or the third option that we have is what's called cover and modify. And that's really what we're going to be talking about today, is how do we cover the scenarios that we have currently with tests and then modify the code safely. So assuming we need to make a change to that app, how much time do we have? That's a question you need to ask yourself. Is this something that has to get out today, or do you have some time to tidy up some things before you get this piece of code out? So let's hit the first scenario. Let's say you need to get this added today. So what options do you have at your disposal? Well, you need to look through your application and find the place where you need to put the code and find seams in your existing code. And then you need to make the minimal changes to the untested part of the code using one of two techniques, sprout or wrap. And we'll talk about what those are here in a second. But really you need to avoid just adding like, oh, I'm just going to add a few lines to the existing mess, right? Like it's already a 1,000-line function. I'm just going to add a few more. What's a few more, right? Well, the problem is everybody had that same mentality when it was 500 lines and 600 lines and 700 lines. And eventually, like somebody's got to put draw a line in the sand and say like, okay, no more. We're not going to keep adding to this mess. We're going to start evolving this thing into what we want it to be. But the key here is we need to do the minimal pieces that are that we need to achieve the story that we're trying to accomplish without refactoring the whole world until we get those tests in place. And we'll talk about that here in a second. So again, you need to focus on your task at hand. So we're going to first talk about the Sprout technique. And if you Google Sprout and Wrap for Sprout, like Sprout legacy code, this will pop up. So this isn't something I made up. This is a well-established pattern. So the Sprout technique is basically, hey, whatever new behavior that you have, go put it in a new class or function or method. And then you can test drive that behavior. So you can test it in complete isolation from the rest of your application. And then you insert or sprout that new code into the existing code. So you put that new tested code into the existing code of where it needs to be in order to achieve that behavior. And with this technique, you do leave the existing code untested because, again, you don't have the time to actually put existing tests around, that 1,000-line function. You just insert it into the spot of that 1,000-line function that it needs to be. And then that's pretty much the Sprout technique. So there's not really too much to it. You just isolate your behavior inside of its own little world and then sprout it to where it needs to go. So the other technique is what's called Wrap, which is pretty similar to Sprout. But this technique only works if you need to add new code to the beginning or end of a function. It doesn't work if you need to like put it in the middle. So you'd have to use Sprout for that kind of scenario. But really, there's just 3 steps to Wrap. Step 1, you take all the existing code that's in that function and extract it out to another function. So if you have a 1,000-line function, you extract those 1,000 lines out to its own function. And then you call that extracted function from your original function. So if you have, your parent function that had all the 1,000-line codes and you extract it out to, a child function, you would then call the child function from the parent function. And then basically you insert, again, you can test drive that code in isolation, the change that you need to make, and then insert that test-driven code either before or after that extracted function. So it's very similar to Sprout in that way, but it allows you to safely use those refactoring tools to extract out the existing code into another function, which is safe, and then put the new code either before or after that mega function call that you just extracted out. So when to use one versus the other? Again, these are techniques you can use when you need to make a change like immediately, and you don't have time to do the next techniques that we're going to talk about, where we kind of cover the existing application with automated tests. Sprout and Wrap are very close to the same thing. The biggest difference is you use Wrap when the new code that you need to add is either at the beginning or end of the function that you're adding it to, not in the middle. And if it's in the middle, that's where you'd use Sprout to put that code in the middle of the function. All right, so that was if you need to make this change immediately, but let's say you have some time to kind of do this right, like you've gotten that green light from the rest of your team, and this isn't a major bug fix that has to go out immediately. You have the time to do this right. So we want to avoid the great rewrite again, because the great rewrite is very expensive and very risky, especially when you don't understand the current system, because I find this a lot of times of like, oh, we're going to rewrite it. What's the current system do? Oh, I have no clue. And it's like, well, by definition, we're unqualified to rewrite a system if we don't understand what the current system does. As well as the great rewrite delays new feature development, because you essentially pause all work on the existing system and then build up this new system and try to get feature parity with it. So we delay delivering value to our end users. And oftentimes with big bang rewrite, there's no iterative steps. So without those tests in place, you essentially are doing a form of edit and pray, where you're just trying to replicate the same functionality on the new system from the old system, but hopefully in a cleaner way. But you don't have those tests in place that tell you, hey, you're on the right track. So this is where I would say don't try to rewrite the entire app, and instead try and focus on pieces to evolve as you go. But before you start slicing off your application, you need to understand your current state. Because again, you can't properly re-architect without understanding that slice of functionality that you're trying to make better. As an aside, I'm also not a fan of moving the application logic or API logic and changing the database schema at the same time, because you're often changing a lot of variables at that point. So usually I'll have like my application logic or API logic that is what I want it to be, and then I just have like some translation layer to the database that might be like in some gross state that I don't want it to be in. And then once the application logic's kind of under control, the API logic's under control, then usually it's a lot safer to then migrate the database. But switching both at the same time changes your inputs and outputs. And we'll talk about that here in a second, about why that can be problematic. So how do you code? So there's a 4-step process. So step number 1, get the ecosystem stable so you can contribute to this code base in a safe way. Number 2, we need to understand what the application is doing. Number 3, add some sort of characterization or integration tests around the existing code. And then finally, we get to the fun part, which is refactoring the code. So steps 1 through 3, you can technically do in parallel and share that responsibility across the team. But really, you need steps 1 through 3 in place before you can safely refactor the code and evolve the code in a safe manner. So what do I mean by get the ecosystem stable? So step number 1, like, is it in source control? Like, you'd be surprised how oftentimes a lot of these legacy systems like aren't even in source control. And then, is there a reliable CI and CD pipeline? Like, can you safely push out changes, or is that a manual process, and what's involved in that process? So we need to get a safe CI/CD pipeline in place. And also, like, a lot of times, like, can you even compile the application? Like, let's say it's in source control, but you pull it down and you can't even compile. Like, we need to get that fixed as well. So we need the contributing model to be in a stable place before we do anything else. Next step is we actually need to understand the application. So if you get dropped in to like this legacy app that you've never seen before, you need to understand what it's doing. So you need to add logging throughout the system, add metrics to see, what are response times, things like that. Can you drop in some sort of instrumentation tool like New Relic, App Dynamics, Dynatrace, Azure App Insights, some of these where there's really not much configuration. You kind of just drop it in and it gives you insights into like what response times are, what queries are taking a long time, what methods are taking a long time, all that kind of data. I also like reading the code and drawing little diagrams of like how the code works. That's also a helpful way to understand the application. And another helpful tip is to just start refactoring the application, even though you don't have any tests around it, just to kind of get a better sense of like, okay, this changes this over here and how these things interact. But then after you're done with that exploratory refactor phase, just throw away the work, because again, you were just trying to get some understanding of how the application works. Step 3, you need to add characterization tests. So once you kind of know the inputs and outputs of your system, you can start adding tests. And you want to write as many black box tests as you can. So let's say you have an API that's in some legacy code state. Basically, we need to know the inputs to that API and then what the outputs are. So like, what's the request model that we're sending into that API? And then, where's it persisting that data? Is in a database, whatever it is. And writing these characterization tests that just black box the implementation code as much as possible, because at the end of the day, once we get these tests in place, we want to be able to make changes to like the guts of the application without these tests really changing at all. And so that's why I'm talking about like, changing the inputs and outputs at the same time. So like if you're changing the database logic at the same time as your application logic, your outputs aren't reliable. So doing that in a secondary step after you get some of these things in place is usually useful. And when you add these characterization tests, you're really going to get an understanding of how this code works, because you're going to write all of these tests that kind of describe the behavior of the system. And then now you're like, okay, now I understand what this code is doing, which will then help you and inform you when you go to the refactor step next. And you want the safety net. So when you're refactoring in the next step, that you didn't break anything. But there's a paradox here, right? Like, I need to add tests so I can change the code, but oftentimes I can't test without changing the code, right? Like, let's say you have the production credentials hard-coded. You'd obviously have to make a change so that you're not pointing your tests at production, right? So this is where you want to be really careful and do the absolute bare minimum changes to allow for testability. So swap out that database connection hard-coded, a production hard-coded connection string for, something you can point at like a local Docker database or whatever the case may be. But again, do the absolute bare minimum that you need to do to allow for testability and nothing else. Don't clean up anything else other than just the bare minimum to be able to swap these dependencies in and out. And now that you've got that in place, you can go to the fun part and what you were doing this all for in the first place, which is refactoring the code. So now that you have those integration tests and those characterization tests that tell you the behavior of the system, you can now safely refactor because those tests will tell you if you broke something along the way. So you can make a change, run the test, and repeat this process over and over and over again. But my advice is get back to green as quickly as possible. So don't be in this, long red state where you're broken for, hours or days on end. Try to stay as green as possible while you're doing this refactoring phase. And just keep repeating this process and keep refactoring until the code is in the state that you want it to be in. So that's kind of the 4-step process of when you do have time of what you can do to safely evolve your legacy code from what you've got today to where you want it to be tomorrow. So some takeaways I hope you got from this. I hope evolving will be the new default, not rewriting, because I think as an industry, software industry, kind of our default is always like, oh, we want to rewrite. And instead, I think we should be more have an evolutionary approach instead of defaulting to rewriting. Hopefully you get some awareness to Sprout and Wrap as techniques to deliver value quickly when you need to get a change out the door. And then when you do have time, the 4-step process to kind of get things into a stable state and then be able to evolve that legacy code in the future. So some resources, this book, Working Effectively with Legacy Code by Michael Feathers. It's where a lot of the content from this talk came from. So that's a resource, and also post the slides as well. So I left it intentionally detailed so you can kind of get the gist of what I'm saying without having to rewatch this whole thing. I'll throw it back to Elise.
Yeah, thanks. Yeah, thanks everyone for joining today. I put the feedback form in the chat along with our next Lean Bites. Just a reminder, we have those external ones on the first Tuesday of the month. And the next one is with Peter about how to level up your digital transformation. So cool. I will go ahead and post this in Slack and send out an email to our external guests. So thanks for joining again, everybody.